Hello, everybody. So this is the video dealing with section 9.3, the parabola. And this is going to be a section where we are going to have two videos. The first one, we'll talk about the standard form of the parabola, position at the origin. And in the second one, we'll discuss translations of the parabola, where the parabola is centered at another location other than the origin. Okay, so on a previous course, you've covered, especially in your algebra course, you've covered the parabola. So the parabola is the name that we give to a function that looks like this. It's parabolic shape, it's graph. But normally, we used to see the parabola either up like this or facing down like that. So we call the one that opens up, concave up, and the one that opens down, concave down. Okay. Now, the equation of the parabola that you were familiar with was ax squared bx plus c. So this is the quadratic equation, and its graph is a parabola. Now, a cannot be zero. And these numbers can be, and B and C can be any numbers, positive, negative, or zero. A cannot be zero. Now, so what we have covered in a previous course was that if A is greater than zero, then we have the situation where the parabola is concave up. And if A is less than zero, we have the scenario where the parabola is concave down. Okay, so the way that we have the parabola here in this previous algebra course, it's in a format where the parabola is really a function, right? That's why it can open either up or down. In this course, in a pre-calculus course or a more advanced course, we have a situation as you see over here. Okay, so this is also a parabola. And it's opening to the right. So we'll have a situation that we can either have a parabola that opens to the right or a situation where we have a parabola opening to the left. We'll discuss that in a couple of minutes. But the main idea is a parabola is a curve like this where uh, we have a couple of distances here that are fixed from this directrix to the focus right here. Okay, so the definition is here, a parabola is a set of all points in a plane that are equidistant from a fixed line. That's the directrix, this line that you see over here, and a fixed point, the focus. Okay, which is right here. All right, so the distance would be, for example, this would be one distance, this would be another distance, and so on. So all of these points on the blue line on the parabola um, satisfy those two criteria. Okay, so this is what a parabola is. All right. Now scroll down a little bit, and we are going to focus on the thing that's a little bit new. So you're familiar with the parabola that opens up and down, right? So those are common. And we're going to cover the new one, which opens right or left. But the equation of the parabola in standard form, it's not the one that we used before, ax squared bx plus c, because this is only applicable if you have a function. Now, the one that opens right or left is not a function, as you can see, right? So if I have a vertical line here, the vertical line intersects this curve in two locations, so that does not satisfy the vertical line test to determine if the graph of something is the graph of a function. So this is not a function, okay? But it's still a parabola nonetheless. So the standard form of the equations, not a function, the equations of the parabola are given by either this or that. Okay. The one that you see on the right is the one that will open up or down. Okay. So if I have an equation that is y equals x squared, this is the parabola that opens up or down. So it's right here below. If we have a parabola that is x equals y squared, that would be a parabola that opens right or left. Okay. So the first thing that we need to know is this. We need to be able to distinguish which is the one that opens up or down, to the one that opens right or left. Okay. So this one is right or left. This one is up or down. Now, the key points of the parabola that we need to know, and we may need to graph it, or at least the sketch of the parabola, is we need to be able to know the shape of the curve, which is this. We need to know its central location, where the parabola is positioned, which we call vertex. We need to know the focus, which is a key point into the parabola. And we need to know this fixed line called directrix, which is opposite to the focus. It's a dashed line. Now, the distance between the directrix and the vertex and the focus is the same. We specify that by the variable p. Okay, so it doesn't matter if it's up or down, right or left, it's the same p. So here's the vertex. I'm sorry, here's the focus, here's the vertex, this distance is p. Here's the directrix, here's the vertex, this distance is p. Now, once we've determined if I have a parabola that opens up or down, or right or left, then we take a look at the p. And I will discuss that in a minute. If p, so here is the information that we need. For the parabola that opens up or down, if p is positive, the parabola will open up. If p is negative, the parabola will open down. For the case where we have the parabola opening right or left, if p is positive, the parabola will open up. P is negative, the parabola will open down. Okay? Now, these two equations that you're seeing right here, or the ones that are here on the right, I'm sorry, on the left, they are all positioned at the origin. The vertex is at the origin. In the next video, we'll consider parabolas not centered at the origin. They're translated to some other location. But for now, we're only looking at the origin. Okay, let's take a look at a couple of examples. And you see exactly what we need to do. And just keep in mind that this is the equation that we need to know. And I'm going to write it right here so that you have access to it as we do the examples. Okay. Okay. So this one, all right, as you can see up here, right or left, right? This one, which you're somewhat accustomed to, you've seen it before, y equals x squared. This is the one that opens up or down. Okay, so knowing this, let's scroll up here. And then we have to remember about the piece, right? In this case, in the first case, where the parabola will open up or down, if P positive opens up, if P negative opens down. In the second case, with the right or left, if P is positive, opens right, if P is negative, opens left. Okay, so the equation is going to be given to us, just like you see here in examples 1 and 2. Let's take a look at the first case. So first, we identify this as one of the two cases, right? So y squared equals 12x is the second case because I have the y squared component. So that means this parabola opens right or left. Okay. Next, I have to write the 12x in the form of 4px. So every time when you have a parabola question like this, you will have to factor the number 4. Okay. So this will be, you always pull out a 4. You don't touch the x. And here you have the number after you factor the 4, right? 4 times 3 is 12, so this is correct. The number inside of the parentheses is your P. This is P. In this case, P is greater than 0. Since this is the parabola that opens right or left, P greater than 0, this would open right. Now, I am going to sketch the graph. This parabola is centered at the origin 0, 0. This is the standard form at the origin opening right. So let's see if we can graph this. Okay, so this is my parabola. The vertex is at the origin. Right? This is the vertex. The focus is here. Now label F. The directrix is always opposite to the focus, to the other side of the focus. So in this case, the directrix is going to be here. Okay? In this case, because the directrix is crossing the x-axis, its equation is going to be x equals something. All right? Now, the p-value is 3. So this distance here is p, and this distance here is p. So I need to find the location of the focus, which is obviously 3, 0, because this parabola is at the origin. The location of the directrix, or more correctly, the equation of the directrix is x equals -3 because it's 3 units to the left of the origin. And this is the graph that we need to be able to provide on an exam, for example. We need to graph the parabola, we need to have the location of the focus, and we need to have the equation of the directrix. Okay? Now let's see the second case, or the second example. In the second example, I have x squared equals -8y. Now, this is the case similar to the first, where I have an x squared component. So this is the case where the parabola will open up or down. In order to determine if it's up or down, I need to find P. And to find P, I'm always going to need to factor the 4. So you're going to rewrite the parabola. You're going to pull out a 4, not touching the y. And inside of the parentheses, you're obviously going to have the number that multiplies 4 that gives you a -8. So -2. So in this case, my p is negative or less than 0. Okay? It's never going to be 0, obviously. So either positive or negative. So in this case, it's less than 0. Well, if this is the parabola that opens up or down, p less than 0, this parabola will open obviously down. So I can immediately begin the graph. So here's my parabola. The focus is always inside of the parabola. This location is the vertex, which is at 0, 0 at the origin. And the directrix is going to be opposite to the focus, always parallel to the parabola. So in this case, the directrix is here. Now, because the directrix cuts the y-axis, its equation is going to be y equals something. Don't write x equals something, y. Y equals something. So on the parabolas that are up and down, the directrix is y equals. The parabolas that are right or left, the directrix is x equals. Okay? Now, all I have to do is find p. But I already know what p is. P is -2. So this distance is 2 units, 2 units down. And this distance is 2 units. Because this is the origin, the focus is at what location? The focus is 0, -2. Now notice it's 0, -2, not -2, 0, because the coordinate that's changing is the y, right? Not x. I'm on the same x position. For the directrix, I am going 2 units up from the origin. So the directrix is located at y equals 2. Okay? So this is the graph, and we need the directrix, we need the vertex, and we need the focus, and obviously we need the curve itself. Okay? Now, somebody might be thinking, well, Professor, what if we cannot factor a 4? Well, we are always going to be able to factor a 4. So, for example, imagine that we have an equation that looks like this. Okay? So again, we identify this as either up or down, right or left. But this is the case where I have x equals y squared. So the y square is right or left. So this is a right or left. Next step is I have to factor a 4. So you're going to pull out a 4, parentheses x. So inside of the parentheses, you have to put something that after you multiply the 4, you have -5. Well, but this is obviously -5/4, right? That's what it is. So now my p is less than 0. So because p is less than 0, this parabola opens left. And you see how easy it is. Doesn't matter what numbers we give you. This is always going to work. Parabola opens left. Okay. This is at the origin, the vertex. Focus is here. And here is the directrix. And this is going to be x equals something. Now the distance from here to the directrix is p, and same thing here. So the focus is at what location? negative 5 over 4 comma 0, and the directrix is at positive 5/4. Okay, so it doesn't really matter what kind of an equation we give you, even if the number is not factorable by 4 in terms of whole numbers, but you can see here that I can always factor a 4. Now, don't factor a negative 4. It's always positive, right? It's positive because the equation needs to match the standard with the positive 4 here. And this is all that we have to do in terms of the first part of the video, which is the standard form of the parabola position at the origin. The next video will discuss its translation from the origin.